In the last segment, I told you to complete these structures, so I filled them out over here. So you need to check your work. Okay, here's the expanded, here's the collapsed, and here's the tally of everything. Here's the expanded, here's the collapsed, and here's the tally, and so forth. And what I said was work your way up to C10, and what you should have counted is that you have 22 hydrogens. All right, so we're going to move on and say, okay, so we have a new definition for saturated or unsaturated. In Unit 6, we said saturated has the maximum amount of solute. Unsaturated has less than max. Now, as far as carbons are concerned, saturated means maximum number of hydrogens. Okay, so 4 hydrogens, 4 bonds, 4 bonds, 4 bonds. And so all of these are showing the maximum number of hydrogens that you can put on if these carbons link together in the way they do. Unsaturated means somewhere along the line you're going to lose some hydrogens. And therefore, what this means is you're going to get a carbon-carbon double bond or a carbon-carbon triple bond. So let's see how that's going to look for us. Okay, so let me come up with a structure like this. Let's say I'm going to take my 6 carbons, 1, 2, 3, 4, 5, 6, and then I'm going to fill in with hydrogens. Okay, C6H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, C6H14. Okay, an isomer. An isomer means I want to take my 6 carbons, but I don't want 6 in the longest continuous carbon chain. So if I do this, for example, I still have 1, 2, 3, 4, 5, 6. So this is the same as that. So no go. So you can take some pennies, and I would encourage you to take some pennies. Okay, put your carbons like this. Break 1 off, or you can even break 2 off. Move them somewhere else. Okay, so now what we have is 1, 2, 3, 4, 5 in the longest continuous carbon chain, and that is a branch. Okay, 1, 2, 3, 4. Okay, so I've drawn here what I've outlined here. This is the longest continuous carbon chain. There's 1, 2, 3, 4, 5 carbons, and this is a 1 carbon branch. Okay, still has the formula C6H14, and we're going to call these saturated because we have the maximum number of hydrogens. Okay, so now what I'm going to do is I'm going to write C6H12. And what that means now is that I have lost 2 hydrogens. Okay, I've lost 2 hydrogens. So I'm going to start with my 1, 2, 3, 4, 5, 6, but I only have 12 hydrogens to put on there. So I'm just going to assign them, and you can do this any way you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's all the hydrogens I have. And what that means is, remember from our Lewis structure, make carbon happy, make carbon happy, make carbon happy. So this carbon only has 1, 2, 3 bonds, which means I have to put a double bond there. And that's what makes this unsaturated. Okay, now there are lots and lots and lots of opportunities for drawing isomers. There are lots of options. I can move the double bond here. I can move the double bond here. Okay? If I move the double bond here, that's the same as it being over there. Okay, so I'm going to draw a couple. 1, 2, 3, 4, 5, 6, and then let me put the double bond there. So that would be an isomer. Or 1, 2, 3, 4, 5, 6, and I'm going to put the double bond somewhere else. Okay? Recognize that when you have something like this, that this is the same as that, because the double bond is between the first and second carbon. Double bond between the first and second carbon. Okay, now I'm going to go from C6H12 to C6H10. I'm going to lose 2 more hydrogens, and we would expect that we can either create 2 double bonds, or I want to make my point, I want to create a triple bond. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I had to put my last hydrogen here because this carbon has 4. Now I can make 2 double bonds, but I want to make my point to show you that usually our progression is going from single bond to double bond to triple bond. Okay, and this is still unsaturated. Isomers, remember, 1, 2, 3, 4, 5, 6, that this is the same as that. Triple bond between the first and second carbon, triple bond between the first and second. So these 2 are the same, these 2 are the same, these 2 are the same. Okay, so I can just create whatever I want here. I'll put a triple bond there. So that would be an isomer, or 1, 2, 3, 4, 5, 6. I could put a triple bond there, or 1, 2, 3, 4, 5, 6, put the triple bond there. Okay, so there are lots and lots of opportunities. Practice, 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 practice. Again, you can use low-tech pennies or something like that. But what you want to do is you want to link the carbons together, find the longest continuous carbon chain, and find out how many hydrogens you can put on there. Okay? All right. Now, since we're running out of time a little bit, okay, I'll come back and provide another example here. Actually, you know what? Why don't I do C5H10? And then we'll come back and you check your work. All right, so now I've got this enormous categorization of compounds. And I said we've got our ionic, and we have our simple binary molecular, and our acids, and we have this whole world now we can call saturated, unsaturated. But that's kind of like having an alphabet that has 2 letters, an A and a B. That doesn't really do much for us. So what we want to do is we want to try to take this enormous quantity of compounds, and we want to try to categorize them. Okay, so that's going to be code for naming. So now we're going to introduce organic naming or nomenclature. So I want to remind you that we learned how to name ionic. We learned simple binary molecular. Acids, I gave you a list, okay? And so we spent a bunch of time talking about how to figure out if we have ions, and then how to name the ionic compounds. How to figure out if we have simple binary molecular, and how to name them. And our acids, there's a list. Okay, so you need to review this because this is going to be part of your exam 7, is to go back. At the very least, you need to finish a chemistry course being able to name the different substances. Okay, so this is my reminder here. You need to go back to your earlier notes and remind yourself about this whole process. Okay, so I'm going to leave you with, why is this such a big deal? Well, this whole pot of carbon compounds is going to be basically infinite. You have so many of them that you can't just say, here's a list of ions, here's a list of polyatomic ions, there's 10 over here, there's 10 over here, and we're going to make a few compounds. That's basically what we've done before. Now we have infinity and beyond. So we have to start this at the beginning. And that's going to be what we call alkanes, and that's where we're going to start the next segment.